Hello guys, so this is the second day or second episode of me preparing for OCP 17. So today I'm going to talk about the primitives data types in Java. So there are two types of data, primitive and reference types. So reference types are object, and this video is about a primitive. So there are 8 primitive data types. So let me walk you through. The first one is Boolean. So it is either true or false, few false, yeah, something like that. And the next one is byte. This is an integer, or they say integral type. 8 bits, mean value is this, and max value is 127. The short is longer than bit, that is 16, right? 16 bits, and this is the mean and the max value, integer, and we have integer, which is another integer, and integral value is not, yeah, integral value, and the mean and the max is here. So roughly from minus 2 billions to positive 2 billions. So you may find this is quite similar if you know about the number of IP address. This is the same amount as storing the IPv4 address. So then we have long 60 bits, integral type. That means we have not having something after the decimal point, so it's not something like have fraction, so it's represent integer values. So from this number, I don't even know how to pronounce this number, so very long. So when the number get very long, you can use this, the underscore, to store the number, but you see that this will not compile. You see the red wiggle line here, because the compiler will think this is an int, and this is obviously not an int because it's out, it's overflow the value of an int. So this is okay, right? But the other thing is not okay. So in that case, you need to put the letter L after the number, or better, you put the uppercase of L. So it will make things easier to read. But then we have float, and let me see what's wrong here. The float is white. Okay, so f is already defined. My bad, somewhere around here. Okay, f1. Okay, so we have float here. So to declare a float, you need to put a number, a decimal point, and this f. So let me try if you can define f3, and it is valid. So sorry, it's f9. Okay, still valid. So to declare a float, you need the f letter f after the number, the value. So yeah, so there are some cases that it will not compile if you have something like this. Let me, yep, something like that. It is better. So this one will not compile because the compiler will think the value on the right hand side is a double, and you declare the type of f1 is float. So there's a type mismatch. So what can you do? You put an f here, and same here. So the compiler thinks this is an integer, and you declare it as float, so it doesn't work, but this will work. Yeah, so we see F3 and F4 here, and next we have double, and it is 64 bits, and we have the bounce here, and finally the final primitive type is character. So we have a char here, C. It will actually represent as a number. So yeah, so smart. Okay, that's just GitHub Copilot. You should consider using it. Yeah, so if I no, not this one, C1. So actually this will print true, and you see that is always true here. Okay, it's always true. So because actually it's the same thing. Number 47 as a car is also letter A. So the next thing we're going to talk about is to declare numbers in other bases. Like we have the most common and the one we are most familiar with, that is base 10, but you can represent base 2 with a prefix with 0 and B, something like that. And base 8, and a prefix with 0, and base 16 from 0 to 9 and A to F. So you find this used very frequently in color RGB thing. So the RGB use hexadecimal number base. So we'll continue with casting. Where did I go wrong? There's an error. Oh, something down here. Okay, so the implicit casting is when you go from a smaller type to a larger type. So for example, we go from short, as you remember, it's 16-bit to int, and there's no problem. Or like here, from int to long, there's no problem because there is no precision is lost. So you move things from a smaller bucket to a bigger bucket. That is not a problem. But when you move from a bigger bucket, things from a bigger bucket to a smaller bucket, then there is a possibility, not always, possibility that some precision will be lost. So for example, we have a long here, and you see that number 2 is well inside the range of an integer. But if I put this, I declare the number integer and assign to this long value, and the compiler will complain. That is the first thing is right. So the thing is this is type mismatch, and this is not allowed. So you can go from an int to a long, but not the other way around. So if you want to do that, you tell the compiler that I know what I'm doing. So just put an int here. So this is the explicit casting. And next we're talking about overflow. So you know that byte is 8-bit. So yeah, let me double check that. Byte, where we have a byte here. So byte is 8 bits. So the maximum value is 127. So go back to here. So we start by declaring a byte with well in the range of -128 to 127. But if you do this, you cast, we have seed multiple by 20, then that would be 400. It's over the bound. So if you cast this, the result would be something unexpected. You wouldn't see 400, but you see another value. So let me comment this. We talk about char previously. Okay, so that is the last item. So let me run this, and you see how about our broadcasting, and it is here, something very unexpected. So well, I encountered this problem in production code, so probably it's not something you see in the exam, I don't know, but it is important to understand the bound of each data type to avoid errors like this. So thank you very much for watching. That is all for today. So I'll see you in the next video. Good luck and goodbye.